Hello, friends. You're welcome to today's chemistry exposition. So, you're going to be looking at atomicity today under chemistry. Now, before we go into this very exposition, there are certain things you have to know. You have to know some basic things under chemistry, like what an atom is, what an element is, and just those basic things you have to know. Just get to know them quickly. If you don't know them, probably you could just pause this video for the meantime and go learn a couple of things on them and come back. Or probably you could even continue with me. Even as you carry on, you end up understanding what these things are. But today we are strictly looking at calculations on chemistry, and today's calculation is calculation on atomicity. So what's atomicity? What's atomicity? Atomicity of an element is the amount of atoms present in a given molecule of the element. So when we talk about atomicity of a given element is simply the amount of atoms present in a given molecule of an element. Now when we talk about molecule, what's a molecule? A molecule is simply a couple of atoms in a combined state. Molecule could be either identical molecules or non-identical molecules. For example, look at these examples that we have here. We're talking about, for example, monoatomic. Argon is a monoatomic element. Argon has only one atom. Argon Ar, just one. Sodium, that's known as natrium. Natrium is a Latin name for sodium. Sodium has just one atom, which is Na. And also, let's look at the other one, diatomic element. Now, look at this diatomic element. These ones, I won't call them atoms anymore. These are molecules. Most of the gases are diatomic in nature. So we talk about oxygen, for example, O2. How many atoms of oxygen do we have here? We have 2 atoms of oxygen. So oxygen is a molecule because of the fact that we have 2 or more atoms. Now look at it, just 2 atoms for oxygen. And also you could have examples like HCl, hydrochloric acid, hydrogen and chlorine combining together to give us that molecule also. So we have chlorine. Chlorine is diatomic, 2 atoms of chlorine. That's how we call it diatomic. Unlike argon, that is just 1 atom. Sodium, that is just 1 atom. And lastly, let's look at another kind of atomicity. We have triatomic elements. Triatomic elements are elements with 3 atoms, just like ozone. Ozone is an allotrope of oxygen. We have O3, this O3 here, ozone. Ozone is triatomic in nature. Why? Because it has 3 atoms. So that's that. So let's quickly go to the part of the calculations. So when we talk about atomicity, the formula for atomicity is simply relative molecular mass divided by relative atomic mass. Now, relative molecular mass is the same thing as 2 times vapor density, or 2 times relative vapor density. That's what relative molecular mass is. Now, what is relative molecular mass? Relative molecular mass is the same thing as molecular mass, but this time around we're talking about the mass of a molecule in relationship with carbon-12 atom. So relative molecular mass is simply the amount of times a given mass of a molecule is heavier or as heavy as 1 atom of carbon-12 atom. That is what relative molecular mass is. So the next we have is relative atomic mass. Now what's relative atomic mass? Relative atomic mass is simply the mass of an atom in comparison with 1 atom of carbon-12 atom. So that's what that is. So atomicity is RMM over RMM. So look at this example. These are worked examples. This is a worked example, The first worked example is this. An element has its relative molecular mass to be 124 and its relative atomic mass to be 31. What is the atomicity of the element? Now, how do we solve this? How do we get the atomicity for this element? Now, don't forget that atomicity is relative molecular mass over relative atomic mass. So let's see what we're given. We are given the relative molecular mass to be 124 and the relative atomic mass to be 31. So what's atomicity? Atomicity is simply, very simple and direct, 124 divided by 31. Now 31 year 1, 31 year 4. So the atomicity of this very element is 4. It means this very element has 4 atoms. Now here's another question. Question 2. The relative vapor density of an element is 15 and the relative atomic mass is 30. What is the atomicity of the element? Now this is also very simple. We all know the formula. The formula is atomicity is equals to relative molecular mass over relative atomic mass. Now, relative molecular mass is what? Relative molecular mass is 2 times vapor density also over relative atomic mass. It means provided we are not given the relative molecular mass, we can also solve if we are given the vapor density. So this time around, we are given the vapor density to be 15. Vapor density is 15. And also the relative atomic mass is given already, which is 30. So what do we do this? What do we do here? We do this, RMM is 2 times vapor density. Vapor density is 15 divided by RAM, relative atomic mass, which is 30. So 2 times 15 is 30 divided by 30. Then you divide that. 30 and 30 is 1. So the atomicity for this very element is 1. So try these questions out yourself. These are take homes. These are the things I want you to try out. Attempt them and leave your answers in the comments section. So the first question is this: the atomicity of an element P is 4. What is the vapor density of the element when the relative atomic mass of the element is 20? So as you can see, the question is very clear. Solve this up and leave your answer in the comment section for me. Now the next question, the second take home, is what is the atomicity of an element Q if the relative molecular mass of the element is 254 and the relative atomic mass is 127? So at this very junction, we're going to call this very exposition a day. So if you have found this resourceful, please subscribe to this very channel and share this exposition. Thanks. See you in the next exposition.